Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter thermodynamics. The chapter thermodynamics. In this thermodynamics, today we are learning about how to measure delta U and delta H practically by doing experiment. Already we know that delta U. What is meant by delta U? Delta U is change in internal energy. What is that? Change in internal energy. Right? Delta H is enthalpy change or change in enthalpy. Enthalpy change. Right? So already we have discussed in the previous video the relation between delta H and delta U, where when gases are involved, delta H is equal to delta U plus delta Ng RT. This is one formula. And we have also discussed that delta U is equal to N Cv delta T and delta H is equal to Ncp delta. These things already we have discussed. Okay. So now practically how we can measure delta U and delta H. So delta U is determined at constant volume. We know from first law of thermodynamics, delta U is equal to Q plus W. At constant volume, what is that? At constant volume, this work done becomes equal to 0. Delta V is equal to 0. So work done is equal to minus P external into delta V. So that is equal to minus P external into 0. That is equal to 0. When work done is equal to 0, delta U is equal to Q. So as volume is constant, I can mention it as QV. So delta U can be taken as heat involved at constant volume. So delta U is determined at constant volume and delta H is determined at constant pressure. Okay. Delta H is determined at constant pressure. Delta H means the total heat energy or heat of a system at constant pressure and temperature is called as H. Okay. So the technique of measuring heats of reactions, and that is called as what? Calorimetry. So we are measuring the heats of reactions or the enthalpy of reactions by using a technique, and that technique is called as what? Calorimetry. The technique is called as calorimetry and that apparatus used is called as calorimeter. Whatever the instrument you are using to measure the heats of reactions or the apparatus which is used in calorimetry is called as what? Calorimeter. And what is the calorimetric liquid? What is the liquid used in the calorimeter to measure these heats of reactions? And what is that? Water. So in this calorimetry, for combustion reactions especially, we are taking one fuel or a substance and we are combusting it. And on combustion, what happens? Heat is released. And by calculating that heat, we are able to calculate delta H and delta U. So by combustion reaction in calorimeter, we are calculating delta U and delta H. That type of calorimeter is called as what? A bomb calorimeter. So in bomb calorimeter, what is done? The substance is combusted and the heats of reactions are calculated. So here bomb is made of steel. See, bomb is made of steel coated inside with the platinum or gold or some non-oxidizable material. See, you are finding bomb here. You look into the diagram, bomb calorimeter, you can find bomb there, right? So this is made of steel coated steel. It is made of steel coated inside with the platinum or gold or some other non-oxidizable material. Next, a known weight of combustible substance, a substance which can be combusted, is taken as a sample here. You are finding sample is ignited, burnt or combusted by passing electric current through platinum wires. So through platinum wires, electricity is passed. The substance which is taken undergoes combustion and heat liberated increases the temperature of water in the calorimeter. So here the combustion occurs. What happens? Combustion occurs at this place. When combustion occurs, heat energy is released. That heat energy will be dispersed into this calorimeter. So here completely it is filled with water. Here it is all completely filled with water. Okay. So when this water along with bomb, everything takes that heat energy and there will be rise in the temperature. What happens? There will be temperature rise. So the substance undergoes combustion and heat liberated increases the temperature of water in calorimeter. The rise in temperature is measured accurately using sensitive thermometer. So you are finding thermometer here, you see. So how much temperature has been increased after combusting the substance which is taken here? And by using what thermometer? Beckman thermometer, you are finding this increase in the temperature, right? So this is what done in the bomb calorimeter. The bomb calorimeter, combustible substance is taken and electricity is passed. When electricity is passed, it undergoes combustion. After combustion, large amount of heat energy is liberated. That heat is absorbed by this water as well as the bomb, and there will be rise in the temperature. The increase in the temperature can be measured by using this thermometer which is in bomb calorimeter. So the heat capacity of calorimeter initially before conducting the experiment, when you are taking one bomb calorimeter, the heat capacity of the calorimeter is determined using what a benzoic acid is taken. So what is taken in this? So benzoic acid. Benzoic acid formula, benzoic acid. C6H5COOH is benzoic acid. This benzoic acid is initially taken in the bomb calorimeter, and its this heat capacity of this bomb calorimeter is calculated. So once the heat capacity of bomb calorimeter is calculated, then by using different substances you can calculate the heats of combustion. So the heat of combustion of benzoic acid is minus 3026 kilojoule per mole. So this is what happening in the bomb calorimeter. We are combusting the substance and we are able to find the heats of combustion. Okay. Next here, when you are combusting a substance in the bomb calorimeter, there will be rise in the temperature. What is that rise in the temperature? Theta. So what is theta? Rise in temperature. Rise in temperature due to the combustion of the substance taken in the bomb calorimeter. So rise in the temperature of water in the calorimeter after complete combustion of the experimental substance. The weight of the substance is m grams. For example, m grams taken. The molecular weight is capital M. The heat capacity of calorimeter plus water. So calorimeter apparatus, total heat capacity of calorimeter setup is Z. So what is Z here? Heat capacity. What is that? Heat capacity of calorimeter plus water. That is the total calorimeter setup apparatus. So M is mass of substance taken. Mass of substance taken for combustion process. Capital M is molar mass. Molar mass of substance. Okay. Then delta U can be calculated by using the formula delta U is equal to Z heat capacity into rise in the temperature into molecular weight by mass of the substance taken. So by using this formula, you can calculate delta Q. So this in bomb calorimeter, the volume is constant. Volume does not change. Hence, heat of combustion, whatever you calculate, how much amount of heat is liberated in the bomb calorimeter, and that will be heat of combustion at constant volume. If you want to convert heat of combustion into constant pressure, then what you have to use the formula QP is equal to QV plus delta nRT. Already we know that delta H is equal to delta U plus delta nRT. Okay. In the same way, delta H is equal to QP. Already we have discussed about that. QP is equal to delta U is equal to QV plus delta nGRT. Okay. So when question is asked, they will clearly ask us what to calculate, whether it is at constant pressure or whether it is at constant volume. They will mention in the question so that we can calculate. QE is nothing but delta U. Delta U means directly you can use this formula and solve the question. Where delta N is change in number of gas molecules. That is the reason why we have written G here. Gas molecules in the combustion reaction. Simply you can say that change in the number of gas molecules, delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. Gaseous products minus number of moles of gaseous reactants. Okay. So this is the formula involved in calculating delta U and delta H. So let us see some P/Q. This is question asked in JEE Main 2022. What is that question? Let us see. 2.4 grams coal is burnt in bomb calorimeter in excess of oxygen at 298 Kelvin and 1 atmospheric pressure. The temperature of the calorimeter rises from 298 Kelvin to 300 Kelvin. So let us write the substances given. Mass of coal given. How much? 2.4 grams. Theta given. How much? Rise in the temperature is 300 minus 298 Kelvin, which is equal to 2 Kelvin, right? The enthalpy change during the combustion of coal, right? So enthalpy change, you can calculate delta H, for example. You are calculating delta H. For the reaction, C coal solid plus O2 gives rise to CO2. This is gas and this is also gas. Number of delta Ng is equal to 1 minus 1, that is equal to 0. So we have 1 mole of carbon dioxide, 1 mole of oxygen. So when delta N is equal to 0, delta H is equal to delta U plus delta Ng RT. Delta H is equal to delta U plus 0 into RT. So delta H is equal to delta U. You can calculate in this way. So if you calculate delta H is equal to delta U, if you calculate delta U, you can get the answer. Delta U is equal to, already we have derived a formula, Z into theta into molarity, molecular weight by M. So what is Z already given? Z is given as heat capacity in bomb calorimeter is equal to 20 kilojoule per Kelvin. So let us take 20 kilojoule per Kelvin into theta 2 Kelvin into molecular weight. Carbon molecular weight is 12 by mass of the substance taken in the bomb calorimeter is 2.4, that is equal to 20 kilojoule per Kelvin into 2 into 5. So 20 into 2 into 5, 10, that is equal to 200 kilojoule per Kelvin. See here, energy is released. So energy is released exothermic. When it is exothermic, we have to mention it as delta U is equal to minus. As the reaction is exothermic, as the combustion reaction is exothermic, always we have to represent delta H and delta U in minus. Understood? So this is one way of solving the question. Another way of solving the question also we can solve. We know that CV is equal to, or heat capacity, simply let us take a heat capacity. Heat capacity C is equal to Q by delta T, right? Q is equal to C into delta T. Q is equal to how much amount of heat is liberated in the bomb calorimeter. C, how much, what is the C? 20 kilojoule per Kelvin into rise in the temperature is 2 Kelvin. Okay, so amount of heat liberated is 20 kilojoules. Okay, amount of heat liberated is 20 kilojoules. So 20 kilojoules is liberated when you burn 2.4 grams. But in the question it is asked a kilojoule per mole. Per mole it is asked. That means when 12 grams of carbon, molar mass of carbon is 12 grams. When 12 grams is combusted, how much amount of heat is liberated? What will be Q then? Okay, and that is called as what? Enthalpy, right? So we can calculate it as delta U. So delta U is equal to 12 into 20 by 2.45 to 200. As delta U combustion reaction, you will have minus 200 kilojoule per mole. So either the way you can solve it. Okay, so the answer is 200. Okay. Next, coming to the question which is asked in 2022. So molar mass is given as 280 per mole, right? Was burnt in excess of oxygen at constant volume. calorimeter, and during combustion, the temperature of calorimeter raised from theta 298.45 minus 298 Kelvin, which is equal to 0.45 Kelvin. Okay. Next, the heat capacity Z is equal to 2.5 kilojoule per Kelvin. And enthalpy of combustion of gas. Enthalpy of combustion of gas, right? So enthalpy Q given as 9 kilojoule per mole. 9 kilojoule per mole. Okay. So how can we solve this question? We can solve in one way that we know the formula heat capacity C is equal to Q by delta T. Enthalpy. So Q is equal to C into delta T. C is nothing but Z. What is that? C is nothing but Z. Z is 2.5 into delta T, 0.45 Kelvin. Q. So this Z, it is given Q already. How much it is given? 9 kilojoules heat energy is liberated when 1 mole of the substance is combusted. That means 9 kilojoules is combusted when is released when what is molecular mass is given 280 grams. When 280 grams is combusted, 280 grams is combusted, 9 kilojoules is liberated. How much we got? How much heat energy is liberated in bomb calorimeter? It is given here. How much? 2.5 into 0.45. Okay. You can see 2.5 kilojoule per Kelvin. Kelvin. So how much is this? Kilojoules. X, let us take how many grams on combustion gives you this much amount of heat energy. So X is equal to 280 into 2.5 into 0.45 by 9. So what do you get? 35 grams. What you get is the 35 grams. So the answer will be how much? 35. In another way, you can calculate delta U. Delta U is equal to, already we know the formula, M by M into theta into Z. That is equal to M by M, right? We want a small m. What you get? M into theta into Z by delta U. That is equal to molar mass, how much given? Molar mass given is 280 grams into theta 0.45 into Z. Z given 2.5 by delta U. How much given? Enthalpy of combustion 9 kilojoules. 9 kilojoules. Then what do you get? 35 grams. Either the way, you can solve the answer. Okay. So this is given in 2023. What is that question? 0.3 grams of ethane undergoes combustion. Ethane at room temperature is in gaseous state. Undergoes combustion at 27 degrees centigrade in bomb calorimeter. The temperature of the calorimeter system, including water, is found to rise by 0.5 degrees centigrade. So what are the given? M, small m given 0.3 grams. Temperature rise delta T or theta, whatever it is you can take, that is 0.5 degrees centigrade. So delta T is nothing but theta. Okay. So heat capacity Z is equal to C. Either C you take or Z you take, same. right? So Z, let us take a heat capacity given 20 kilojoule per Kelvin, right? So you can calculate delta U here. Delta U is nothing but QV. So delta U is equal to capital, we derived a formula into T theta into Z, that is equal to how much? Molar mass of ethane. Ethane C2H6 on combustion gives you CO2 plus H2O. So if you balance this 2, 3, so 3.5, right? Then this is gaseous, this is also gaseous state, gas, and this will be in liquid state. So C2H6 equal to 24, 6, how much? 30. Molar mass of C2H6 is 30 by 0.3 into theta, 0.5 into Z given 20 kilojoules, that is equal to 100 into 0.5 into 20 gives you 10, that is equal to 1000 kilojoule per mole, okay, kilojoule per mole. So this, what did we get is delta U. We got as delta U or QB. But the question asked is clearly during combustion of ether at constant pressure is asked. Constant pressure. We know that here delta Ng, right? Delta Ng is equal to number of moles of gaseous products. Number of moles of gaseous products minus number of moles of gaseous reactants. Number of moles of gaseous product is 2 minus here 3.1 plus 1. So 4.5, that is equal to minus 2.5. And we know we need to calculate delta H. Delta H is equal to delta U plus delta Ng RT. So here delta U, as it is exothermic reaction and amount of energy released is okay, you have to mention it as minus. So next delta U is delta H is equal to delta U, how much we have calculated? Minus 1000. Minus, why did we write? Because it is exothermic, heat energy is released, plus delta Ng, how much? Minus 2.5 into 8.314 into 10 power minus 3 kilojoule per mole per Kelvin. Why did we take kilojoule? Because here this 1000 is kilojoule per mole. So here we have taken it as kilojoule, so we are mentioning it. So what is the temperature? At 27 degrees centigrade, the reaction is happening at 27 degrees centigrade. 27 degrees centigrade is equal to 300 Kelvin. Okay. So then if you calculate minus 1000 plus minus, you get 6.1 something kilojoule, 6.2 approximately. Here it is also kilojoule. So that is equal to delta H will be equal to minus 1006 kilojoule, okay, per mole. So what is the question asked? So the heat evolved, already it is mentioning that heat is evolved. Evolved already represents that minus. Minus represents that heat is evolved. Okay, heat is evolved. How much heat is evolved? 1006 kilojoule per mole is heat is evolved. Right? Next. So this is question which is very much recently asked. A sample of N octane. What is that? N octane. N octane. Alkane. An octane. Octane means 8 carbons are there. C8H 8 16 plus 2 18. What is the molecular weight? Molar mass. Molar mass 12 eights 96, 18 ones 80. How much? 4114. So molar mass is 114. Was completely burnt in excess of oxygen in a bomb calorimeter. Whose heat capacity? So what is given? Heat capacity, let us consider it as Z, that is equal to 5 kilojoule per Kelvin. As a result of combustion reaction, the temperature of calorimeter raised. So let us take it as theta 5 Kelvin. Magnitude of heat of combustion at constant volume is asked. Heat of combustion at constant volume. So only magnitude is asked. No sign. So delta U is equal to, we know formula. What is that? M by small m into theta into Z. So molar mass we have calculated it as 114 by 1.14 given. Mass given is 1.14 into theta. Rise in the temperature is 5 Kelvin into Z, 5 kilojoule per Kelvin. This is Kelvin. Okay. So then what do you get? 100 into 5 into 5. So 2500 minus actually kilojoule per mole. Okay. So heat of combustion is actually minus 2500, but it is asked only magnitude of heat of combustion. Magnitude means only 2500 kilojoule per mole. So simply, mostly the questions are on this formula. We need to remember this formula. Then we can solve questions easily. First of all, we need to understand the question. Then you can solve it. Okay. Remember this formula. That is with the session. In the next video, we shall meet with a new topic. Thank you.